Hello. So in the previous video, I showed you how to download the data and uh, how to understand the structure of the data. And now I'm going to show you how to do the analysis on Stata. So what you see is the Stata, the statistical software, and you can use on any campus computer, like in the library. And if you have any problem in using Stata, let me know. It's important. So the first thing I would like to do is we need to do is to import data. Before doing that, I will change the working directory. Uh, though, so it will be very convenient to choose the directory to where I saved the data. So C drive, hallmark here. So this is where I saved my data. And then I'm going to import data this way. File, import, and CSV file. So remember, the file format we downloaded was CSV. So we will click it and choose the data we have. Where is it? Right here. Homework. Like this. So I will click OK. Then the data is being imported. It's okay. Now we are ready. So you see those area. This area has the list of variables, and properties. I will change the. So this area, you will see the data number of variables. There are 602 variables, and number of observations is 72,000, more than 72,000. By the way, the number of observations is slightly different from what you see from the textbook, because the textbook data is 2005 survey, and what we are doing here is 2018 survey. So because the survey time point was different, that's why we have different number of observations. And the data size is 42 megabytes, about 43 megabytes. So this is how much you need the memory. And currently the memory is taking up, allowed memory is maybe 96 megabytes. So basic things, maybe they are not that important right now. And we are looking at those variables. So we have to clean the data set. First thing we would like to do is to delete all the variables except for the two variables we wanted. What we needed was let's see, the variables we needed was pH stat. This variable pH stat is one variable we are going to use, and right above the other variable, PHOSPYR2, P hospital year 2, and P health status. So those two variables are the only variables we are going to use. Now then, what you are going to do here is we will type this keep. So this area is where you type your command. You input your command here, and then the history of the command will be accumulated here. So it shows what you have done. So now I'm going to type keep. We will keep only two variables, this and this. If you double click the variable list, if you double click the variable, then it will be automatically entered here. So keep PHOSPR2 and PHST and enter. Then all the other variables are gone and we have only two variables. And now then, okay, now we would like to have a look at those variables, and one possible way is to open data editor here. So there are two data editor. One is to edit and the other is to browse. What we need is just to browse. So just open this. Open browse data editor, and then it shows the entry like an Excel view. P hospital year 2, it has variables like 2, 2, 2, 2, 2, 1, 1, 1, 2 and 1s. And so remember, 1 means yes, 2 means no. On the other hand, health status, 1 means excellent, 3 means like 3, 5 means poor. So like this, there are the outcomes are given here. Realizations, survey answers are entered in those two variables, right? And there are more about 72,000 observations. So there are a huge number of numbers in those two variables. Okay, then what we are going to do now is to drop the irrelevant answers. Remember 789 are irrelevant answers we would like to delete. So then I'll show you how to delete that. So we will use drop. So when you keep something, you use keep, and when you drop, use drop. Command drop, type drop, and I will drop if this variable equals to 7. For example, first I'll show you drop if this variable equals to 7. This does not work. Like I will show you, it does not work. So drop if the variable equals 7 does not work, because one equality is not allowed. Instead, I'm going to show you what is the correct way. Drop if this variable equals 7. The main difference is you have to use two equalities at the same time. So equal. The main difference here is, so like when you think about equality, it's too obvious. It's just equality, but more precisely, like to this computer, there are two different meanings. One is definition. So like equality used to define a certain variable equals 7, for example. That is one way of using equality. And the other way of using equality is to check there are two things and you want to compare them. So as a result of the comparison, they may be equal or they may be different. So if they are equal, we use equality. These two ways of using equality are recognized differently to the computer. So the program use different notation for definition and comparison. Equality as a result of comparison. So these two things are different. So when you define something, that's simple equality, one equality. But when you compare two things, then you have to use two equalities. Then it will tell you why we need two equalities here. This is very confusing, but not a big problem. Like when you see this kind of error, then think about this, whether you are using equality correctly or not. So this equality is called as logical equality. Logical, so comparison. logically they are the same or not. It's not about definition or not a command. It's like have the computer think about it, compare them. And similarly, we have to drop 8 and 9, right? So, and the next thing I will show you is OR. So, we would like to drop if the variable equals 8. Again, I'm using two equalities. Or we want to say OR 9. And that is connected by upper bar, vertical bar. Vertical bar, not upper bar, excuse me. Vertical bar is shift the button above enter. So then 9. So this is how you connect two conditions with OR. So this means OR. And if you enter that, like 48 observations are deleted. So this is how you delete 7 or 8 or 9. By the way, in case you want to connect two conditions as AND, then you may use this. So for example, drop if it is 7 and it is 7. This is how you connect two conditions as AND, right? And by the way, there will be no observations deleted because I have already deleted all the 7 observations. So make no change, but this is how you use AND and OR. AND and OR. And we are going to do the same thing for the other variable, pH stat, status, health status. Now I'm going to use this inequality. So they are the same thing. I dropped 7 or 8 or 9, but equivalently I'm going to drop if the variable is 7 or greater, right? Greater than or equal to 7. And then we'll drop those variables. So by doing this, we cleaned out our data. By the way, another way to achieve the same thing is something like this. Keep is exactly the opposite command. Keep if pH stat is 5 or smaller. But there will be no difference because I have already dropped all the variables other than this. So these are examples. These are how we, simple commands, how we clean up our data. And then what I don't like here is health. The health variable is encoded as 1 being excellent and 5 being poor, which is counterintuitive. I want to make 5 being excellent and 1 being poor. So then that's also possible. I am going to define a new variable. Say I will define a new variable named health, and it will have 5 for excellent health status and 1 for poor health status. To do that, first I will define health. I define a new variable health equals to 0, for example. So, for example, I'll define a new variable health equals to 0. And then, as you see, a new variable is defined now. And if you open the browser, it shows simply everything is 0, right? Not a surprise. And what I'm going to do here is I'm going to change the value of this variable according to the original variable health status. Let's see. To change the variable, we have to use replace. By the way, another thing I have to explain here is I used one equality here because this is definition, right? Now, remember, we used two equalities when you compare, logical comparison, when you do a logical comparison. But now, this is literally, it is a definition. I'm generating a new variable and define the new variable as 0. So it is a command, not a logical operation. So it is a command. So you can use just one single equality. If you use two equalities, then you will get another error. It will give you another error. So now I'm going to change like this. I will define, so I will change health to 5 if the original health variable equals 1. So remember, the original variable was defined at 1 if the health status is excellent. But I will define it as 5 for the new variable. And what's interesting here is when I define the new variable as 5, I use one equality, but this is two equalities because it's comparison. If this condition is satisfied, then define health as 5. So enter that. So then changes have been made. And you have to do that for the second best health status. So do the same thing. You can keep doing the same thing, and you have to repeat it 5 times. But actually, this is to explain how you use. I use this way, this method, just to show you the difference between single equality and double equalities. But a better one, I will show you. Replace health equals 6 minus pH stat. If you define it this way, there is it can be done in one step, right? So everything can be done in one step. So if pH stat was 1, health will be automatically 5. If it was 5, it will be 1. So the relationship can be defined what we were about to do in 5 lines can be done in 1 line. So this is the efficiency of programming. When you say someone is a genius programmer, like Bill Gates was, or like Mark Zuckerberg was a genius programmer, then we say like this kind of efficiency. They can write a program, like more compact program, doing the same thing as a longer, more complicated program does. Okay, this is the basic data cleaning. So we have. I'm going to stop here, and I'll continue working on those variables in the next video. Thank you for watching. See you later.